Okay, hello Math 111 students. I've created several YouTube videos going over the course content. So an introduction to statistics is basically the notes for chapter 1 here. And we're not going to do section 1.2 or 1.6, mainly because of time, but I've got all the homework problems listed at the end there for you. Okay, so chapter 1 is really just kind of an intro to statistics. We're going to start with terminology so that we can get familiar with the language of statistics. And it might appear like you're not really in a math class for the moment, although that's going to change. Okay, that'll change in my opinion when once we get into chapter 3 is where you do the more mathematical stuff. Although in chapter 2 there's still mathematical stuff there as well with the graphs. So probably the first question that you might have is, what is statistics? Okay, you might be familiar with probability and statistics through radio, television, newspapers, magazines, and the internet. For example, you may read statements like the following. Eating 10 grams of fiber a day reduces the risk of heart attack by 14%. In the U.S., about 12% of men are left-handed, and about 10% of women are left-handed. Okay, and the average student debt for 2018 college graduate was about $35,359, and that was up 3.5% from the previous year. Okay, so statistics is used in almost all fields of human endeavor, okay, and I've got a bunch listed here. So you find them in health and nutrition, politics, sports, weather, music, crime, education, gambling, polls, and surveys. Okay, and it certainly has a lot to do with the numbers, but it's also where the numbers come from and how closely the numbers reflect reality. Okay. Perhaps a better way to understand the definition of statistics is through this process that we're going to look at here. And it says that statistics is the science of collecting, organizing, summarizing, and analyzing information in order to draw conclusions. Okay, some people say that statistics are just numbers. Okay, and although that's partially correct, there's way more to the definition than saying it's just numbers. Okay, it's a process. Okay, and a process that consists of 4 parts. I've got the process of statistics given below here, and just an example. And we'll go through this example, and I'll highlight some other definitions that we should know. Okay. So the process of statistics. Do you favor lowering the voting age? Okay, this is a real study done. A poll was conducted by Hill Harris X on April 27th through 28th in 2019, asking the question, or to learn how Americans feel about lowering the voting age to 16. Okay, and the following statistical process allows the researchers at Hill Harris X to conduct their study. Okay, so step 1 is we need to identify a research objective. Okay, so it says here in the definition that a research objective is the question, or sometimes it's multiple questions, that a researcher wants answered. So according to what we have here, the researchers wish to determine the percentage of Americans aged 18 or older who are in favor of the idea of lowering the voting age in all states to age 16. Okay? Now, the entire group that's to be studied is called the population. And an individual is a person, or it's an object, that is a member of the population that's to be studied. Okay? So, the population that we're studying here is all Americans age 18 or older who are registered to vote. Okay, and I would say all of that. Okay, and I'll comment on that further once I talk about a sample. But step 2 is you need to collect the necessary information to answer the question that was just asked in step 1. Okay, and the way that we do this is through a sample. Okay, so it says that it's usually not possible to survey the entire group, okay, the entire population. Maybe it's too big or it's too expensive or whatever the deal is. So we typically have to look at a portion of the group called a sample. Okay, so it says here that it's unreasonable to expect to survey the more than 250 million Americans age 18 or older who are registered to vote to determine how they feel about the minimum voting age. Okay, there's just too many people. Therefore, the researchers surveyed a sample of 1,002 registered voters age 18 and older living in all 50 states. Okay. It says of those surveyed, 161 stated that they were in favor of lowering the voting age to 16. Okay. Now, when you're asked to identify a sample, be specific. Be specific. And there's going to be many times we're going to be asked, what is the population? What is the sample? Okay. So, like here, I wouldn't just say 1,002. 1,002 what? Okay. I wouldn't say 1,002 voters. Okay, that's not true, right? Because we're looking at those of a specific age group. Or age. I wouldn't say 1,002 people age 18 and older. That's not true. We're looking at voters. Okay, and also they live in the 50 U.S. states. Okay, and so I would say all of that. Be specific whenever you're asked to identify a population or a sample. Okay, now the bigger the sample, the more information that you have. Okay, that's key. So like for this study, 1,002 registered voters, age 18 and older, living in all 50 states, were surveyed. Okay, what if the researchers conducted a survey of 50,000 registered voters, age 18 and older, living in all 50 states? Well, they have more information now, right? Because there's more people in the sample, okay? Now, sometimes, you got to work with what you got, okay? But obviously we like the bigger and better sample, okay? The bigger the sample, the more information you have. So step 3, after you've got your sample, you want to describe the data, okay? Describe the sample. Of the 1,002 individuals in the survey, 16%, or 161 out of 1,002, were found to be in favor of lowering the voting age to 16. Now, that statement that I just read there, that would be an example of a descriptive statistic because its value is determined from the sample. Okay, and so that's one more definition here. Descriptive statistics consists of organizing and summarizing information collected in a sample, and that's different from inferential statistics because inferential statistics consists of generalizing results from the sample and measuring the reliability of those results in the entire population. Okay, I would underline in the entire population, that's key. So anytime that you're extending your knowledge outward from just the sample to everybody now in the population, that's inferential statistics. Okay, otherwise if you're just making a statement about the sample, that's descriptive statistics. Okay, so this statement here, where it says, of the 1,002 individuals in the survey, 161 out of 1,002 were in favor of lowering the voting age to 16. That's an example of something that's just related to the sample. Okay. And by the way, here's when we describe the data, or when we organize the data, that's the same thing. When we organize the data, this means that we use charts, tables, graphs, okay? When we numerically summarize the data, we perform calculations like the mean, median, mode, standard deviation, percentiles, in order to better understand the entire data set. Okay, we're going to talk about that stuff later, but this is an example of descriptive statistics. Okay, organizing the data is what Chapter 2 is all about. Okay, and that's the different graphs, charts, pictures that we'll look at. Numerically summarizing the data is what Chapter 3 is all about, and that's really where the math comes in, and we'll be performing calculations like the mean, median, mode, standard deviation, percentiles, etc. Okay. Now, the fourth step is, in my opinion, probably the most important one, and that's to perform inference. Okay, and that's where we're going to draw a conclusion. So the researchers at Hill Harris X wanted to extend the results of the survey to all Americans age 18 or older who are registered to vote. Remember, that's the population. When generalizing the results from a sample to a population, the results are, of course, uncertain. Okay? In other words, there's no way to know the actual percentage of all Americans who are in favor of lowering the voting age, right? There's just too many. There's over 250 million people, okay? So the parameter is something that is not known, okay? And we'll talk about that on the next page there, okay? So it says, to account for this uncertainty, Hill Harris X reported a 3.1% margin of error. Okay, this means that Hill Harris X feels fairly certain. In fact, Hill Harris X is 95% certain. Okay, and like I said, this is a real study that was done. They report their margin of error. Okay, but they're in fact 95% certain that the percentage of all Americans age 18 and older who are in favor of the idea of lowering the voting age to 16 is somewhere between 12.9% and 19.1%. Okay, and so that's if you take 16% minus 3.1%, or 16% plus 3.1% gives you the upper bound. Okay, you got the lower bound and the upper bound. Okay, now what I just read to you there is an example of an inferential statistic. Okay, and so an inferential statistic consists of generalizing results from the sample and measuring results measuring the reliability of those results in the entire population. So anytime you're going to extend your knowledge outward towards everybody now in the entire population, that's inferential statistics. Otherwise, if you just have a statement about the sample, that's descriptive statistics. Okay, so what I just read here. The researchers at this company wanted to extend the results of the survey to all Americans age 18 and older registered to vote. Okay, anytime you're going to extend your knowledge outward towards everybody now, that's an example of inferential statistics. Okay, otherwise, if you're just making a statement about the sample, that's called descriptive statistics. Okay, and we'll go ahead and stop right there.